Before I begin, I just want to give a quick shout out to Chris, to Vanessa, to Robbie, all the organizers, volunteers. Big thanks to you guys, because without you guys, we won't be able to pull off this incredible event. So big thanks. Please help me give them a big round of applause. All right, so today I'm going to talk about truth and disinformation in the age of generative AI. Actually, about 3 weeks ago, I gave a keynote in the Santa Clara Convention Center in regards to AI LLMs. I talk about 3 of the emerging problems, and one of them is misinformation, disinformation. The second one is personalization, and the third one is decentralization. And today, I'm going to go deep on this particular issue, truth and disinformation in the age of generative AI. And since I am starting, then I'm going to take a little more time describing what AI, large language models are, supervised learning, and things like that. And I'll get into defining what misinformation, disinformation, defining the problem statement. And last, I'm going to talk about how can we come up with a holistic approach to tackle this particular issue. But before then, just a quick intro. So I'm the CEO and co-founder of Spokeo. We're one of the top 3 people search engines, identity verification services that actually aggregates about 20 billion records into 600 million entities to help about 15 million users a month to search, connect, verify, and know who they're dealing with. I'm also the co-chair of W3C CCG, which is the top self-sovereign identity, decentralized identity, Web3 ID. So some of you guys might have the mobile driver license in your phones. So one of the standards is verifiable credential. W3C verifiable credential is incubated in this community. I'm also the former chair, right? Before even better person took over of the Southern California Monte, which is the biggest Taiwanese American Science and Tech Association. And lastly, I'm the dad of 4 boys. It's the toughest job I ever had, because the other jobs that these people listen or pretend to listen to me. Oh, okay, they're over there, they just arrived. And they don't even pretend.
That's surprising, it's family here.
Yeah, that's right. So if you hear a baby like yelling, that's sorry, that's my 4th one. But yeah, they don't even pretend. So it's actually the toughest job I ever had. So I'm going to take a quick moment because we're going to have quite a bit of great presentations about AI, ML, artificial intelligence, and machine learning today. So I'm going to take a moment to talk about what is artificial intelligence, what is machine learning. So first of all, artificial intelligence, in my opinion, is a somewhat generic word. So historically speaking, artificial intelligence is defined by Alan Turing, who is a very, very famous computer scientist. It's called a Turing test. So what is a Turing test? Turing test is just you blindfold someone, and if that person cannot tell the difference between the response of a human output and the machine output, then the machine is said to have artificial intelligence. That is the historical definition of artificial intelligence. And by the way, intelligence is defined as practical application of data and knowledge, okay, in the English language. But that is the historical definition. As we know, about 2 years ago, in November 2022, ChatGPT arrived, and I'm just like billions of people out there. I'm truly shocked. For the very first time, machines has passed the Turing test. And personally, I think instead of saying that machines have achieved superhuman intelligence, personally, I think we need to redefine what intelligence means. Now, machine learning is part of the artificial intelligence. There's 3 types of machine learning. One is called supervised learning, unsupervised learning, and reinforcement learning. Today, we're going to mostly talk about supervised learning. So what is supervised learning? Supervised learning is essentially a learning where it has labels. So what is a label? Label is existing known inputs and outputs. So supervised learning essentially just maps the inputs to outputs. So when you give new inputs, you'll have new outputs. Okay? It's basically a function. Now, historically speaking in math, we're taught that functions has to look like y equal ax plus b, but that is actually a very restricted definition. The true definition of function is a mapping, and it doesn't have to be linear. It can be a non-linear mapping. And so essentially, supervised learning uncovers through data automatically, maps the inputs to outputs. So when you give it to a new input, you have new outputs. This is the most prevalent way of machine learning. And unsupervised learning is basically when you don't have labels, and reinforcement learning is about reward functions. Okay, so it's kind of like you have a pet, you're trying to train the pet. If the pet does something you want, you give it food, right? So that's called a reward function. So these are the main three types, but mostly we're talking about supervised learning. So the coolest part of supervised learning is that the more data you have, the more records you have, the higher the dimensions. Records is number of rows. Think of an Excel spreadsheet. The more rows you have and the more columns you have, the more generalizable, the more accurate, the more magical the model can be. So imagine in statistics, you have an underlying distribution, right? Now, in national polls, we just had an election. In national polls, it's usually around 1,000 samples. Of course it has errors because there's damn 300 million people in the United States. Now, imagine you can scale that records to 300 million. Guess what? You don't need stats because you have the truth. You only need stats because you have 1,000 or 2,000, right? So what if I can tell you we can jam that number up from 1,000 to 20 million? You'll be more accurate. You'll be closer to the truth. Now, another cool thing, and I'll talk about this a little bit later, is what if we can increase the dimensionality, increase the number of columns and features? Something magical will happen. But generally speaking, that's what's magical about this is the word number large. LLM stands for large language models. Okay, it's what powers the ChatGPT, and the most magical word in that acronym is actually the word large, both in the number of records, but also in the number of features and columns. And by the way, machine learning, supervised learning, there's a lot of applications. We see that in recommendation engines for over a decade, which personally I think is the number one problem that causes the division in our society, but that's another talk. If you're curious, we can ask that. We can have a follow-up conversation around that. Image recognition, fraud detection, and so on, so on, so on. So that's supervised learning. And this is actually the biggest business opportunity. It has been identified by McKinsey as the top 3 tech trends, okay, with 86 billion in equity investments in 2023, right? And then the ML ops is basically the tools, right? Imagine the development operations equivalent of a machine learning pipeline that has about 3 billion. Why is this so important, or why is this getting so much funding? Well, the reason is because supervised learning is fundamentally an optimization problem. Okay, at the end of the day, you have known inputs and outputs. We're trying to fit or create a function that minimizes the errors between the prediction, the model output, and the input. So it's an optimization problem. And guess what? Every application and every industry can be optimized. For example, you can optimize the cost of, in marketing, you want to optimize the cost of acquisition, right? Because you want to acquire customers for cheaper. You know, as another example, you want to optimize revenue. Every business wants to optimize revenue. So an inherent optimizer has multiple applications. And that's why machine learning and supervised learning, primary, by the way, there's multiple types, but primary supervised learning, as I see it, is basically what's driving all these investments, because there are so many rooms for optimization, so many rooms for improvements that we can see. So none of these are actually that crazy. This one is the one that shocked a lot of us, including myself. Okay, I have been in tech for a long time, and this thing shocked me in a very, very deep way, because I did not imagine to see something that can pass the Turing test in my lifetime. So large language models is what powers the ChatGPT and generative AI hype. The magical thing, and fundamentally what it does, is it predicts the next word, okay? But let me put that in the parking lot for a second. Let's talk about a second magical thing, which is what's called word embeddings. One of the things I failed to appreciate for a long time is the depth of human language. I once heard when I was at Stanford that language is the best artifact of human intelligence. I thought that was a beautiful sentence, but I really didn't comprehend what that means until this comes out. A word in English language has to have more than 5,000 dimensions, okay? Dimensions. It's called embedding. It's basically a vector. It's a series of numbers. It has to have more than 5,000 dimensions to be representative. And that's just the beginning, okay? And by the way, so once you represent this, what's magical about this? Well, guess what? You can, you can represent these words, and then you can do mathematical operations on top of it. What's different about embeddings, a kind of encoding, and let's say a hash function, is that embeddings can be operated via arithmetics. So for example, you have an embedding for king. You have an embedding for male, female. Well, guess what? King minus male plus female, it will equal the embedding of queen. Okay. Another example, you can say Beijing minus China plus United States, you'll get Washington, D.C. That's what word embeddings do. Now, even crazier is that human language is more than just words. You have sentences, you have context. So for example, you say, hey, there's a bank on the riverbank, right? It's the same word, but it means different things. It has different contexts. So what you have to do is you have to use that word, and then you have to what's called attention, but really you have to calculate it and compare against other words in that text multiple times. And when you do that matrix multiplication, you're talking about hundreds of thousands of parameters. Well, in these cases, parameters are over a billion, couple billion. That is how deep, how crazy human language is. It truly is the best artifact of human intelligence. So let me get back to this prediction of next word. That's the number one magical thing about large language models, in my opinion. Because when you present a problem as prediction of next word, well, guess what? Even a sentence with 5 words, you can have 4 or 5 labels out of it, right? Because you can just hide, for example, you can just hide the 3rd word, 4th word, 5th word. You can take the first 2 words to predict the 3rd one, and so on, so on, so on. So when you take the entire human language text that humans have on the entire internet, well, guess what? You have gazillions of labels, gazillions. National Polls has 1,000. This has gazillions, like crazy amount of labels, crazy amount of records. Plus the fact that you have thousands and hundreds of thousands of dimensions, something magical happens. This decoder, when you encode the entire human knowledge into this thing and you decode it back, it looked like a human. It passes the Turing test. And of course, there's other things. For example, reinforcement learning with human feedback, you can fine-tune it with human inputs, right? With human rewards functions, right? This is what powers the ChatGPT, and it can do many, many different things. That's why it's called the foundation model, because it's not just language prediction. It exhibits new capabilities, right? You can detect name entities, right? You can do natural language processing. You can do retrieval augmented generation, which is basically AI overview in Google searches. You can do translations just using one model. You know, a lot of people say, hey, what's magical about predicting the next word? Well, what's magical about a switch? When you add billions of switches together, well, guess what? You get a CPU. And CPU powers a lot of these things. What's magical about a single human being? Well, guess what? When you put 300 million people together, we get United States. We get the value of being American. So an entity, which is the entity of entities, is not just a group of entities. It can assume different capabilities and things like that. So predicting the next word might be something easy, but when you actually put it all together, it starts doing something magical. And it's not just the large language models. Obviously, there's other modalities, right? It has image, audio, code, video, and so on, so on, so on. A lot of us have tried these things. And this is what's the number one talk about thing, generative AI. 65% of correspondents said that their companies are trying it actually right now. So it is the cutting edge of AI, artificial intelligence, and machine learning, and that's how it works. And I think we have to really understand how things works, right, before we can actually talk about how it can be applied and how it can actually solve our problems. Now, I took a moment to talk about what artificial intelligence, machine learning, and those things are. Let me talk about one of the problems that it generates: misinformation and disinformation. So what is misinformation and disinformation? So it's a type of fake information. Misinformation is basically false information, whether intentionally or unintentionally, right, shared, right, for something. And disinformation is where it's a false information, but intentionally shared to mislead people. And this kind of things, right, fake news, whatever, it actually creates a lot of mistrust, divisions, and scams and problems in our society. And unfortunately, generative AI can do a lot of things, but one of the unintended consequences of generative AI is that it makes generating misinformation and fake information easy. So these are a couple of examples: fake news, fabricated news or content, AI slop, which is low-quality AI-generated content flooding the internet. You know, there's actually a interesting topic about AI killing AI, because AI needs the internet, right, to train the models. But what if the internet is 80% all AI-generated, kind of boring content? Then what will happen to the future AI predictions? AI slop. That's a real problem today, by the way. Deepfakes, a realistic imitation of someone's look, voice, actions. Actually, there was 2 weeks ago, our security team came to me and talked about, hey, we should do this audit because some company has a North Korean faking that they're applicants and got in and got hired and all that stuff. I was like, wait, hold on a second. Like, I heard the keyword North Korean. What are you talking about? Like, are you joking me here? Is this a movie or something? Supposedly, I look up on the internet, it's actually a real thing. They're using these deep fakes to pass the interviews, get hired, and then hack into the American company systems. So we actually are doing an audit to make sure that our team members are actually real. Synthetic identity, combining real and fake information to impersonate someone. So these are real problems happening today, okay? Now, before you get into it, the solution, before you talk about a solution, let's also talk about what truth is, okay? A lot of people say truth is in the eye of the beholder. I don't believe in that. I think there's one truth. It's just that there are multiple perspectives. So truth is inherently high dimensional. So let me talk about what that means. So for example, here's a little clicker here. If imagine that you can only experience a 2D world, then all you can see is that it's a rectangle, a big one here. On the side is a small rectangle, but you'll never know that it's a clicker. Now, we experience and live in what I call a 3.5D world, because X, Y, Z, and half the time, none of us actually know what the future will be. So the time dimension is just half of it. So you can never know whether this clicker goes to the trash can, right? Or end up in a museum someday. So the truth is inherently high dimensional. And by the way, these are just 4 dimensions I mentioned. There's other dimensions. Humidity is a dimension. Temperature is a dimension. Even personality is a dimension. So there's probably millions and gazillions of dimensions out there. And guess what? We can only experience some of it. That's why we can all have some perspectives, but we can get closer to the real truth, but you can't really get to it. Right, so that's from a physics perspective. From a statistics perspective, earlier I gave an example of a distribution of United States, right? If you sample 1,000, and there's more than 300 million people in the United States, you can get some approximations, but you can't really get the truth, right? So you need more and more data, more and more samples and observations to get closer to the truth. And lastly, and this is my favorite definition of truth, is that truth needs multiple criteria to be assessed. Whether it's correspondence, how it corresponds to the physical world, whether it's consensus, right? Like let's just say, hey, 1,000 people, do all of us agree that this is the truth, right? That's how Supreme Court works, by the way. And that's how blockchain works, consensus algorithm in blockchains. Right? How in the world does a blockchain know that this transaction happened? Well, guess what? It's just a null operator. The majority of null operators says it happened, right? But obviously, that shouldn't be the only criteria of truth, because if that happens, then the Earth will always be flat, because at some point in human history, majority of us thought that the Earth is flat, right? So that's consensus. Authority, right? Which is, hey, someone that we really trust says true, so it must be true, like professors, here. When they say it's true, I usually just take their words for it. But obviously that shouldn't be the case. Otherwise, we should just all move to North Korea and listen to Kim Jong-un's words, right? So, so there's multiple criteria. I'm not going to get into all of these things. But the truth is inherently high dimensional. I believe that there's only one truth, and we can have different perspectives, but we should all try to pursue that truth. And this is important because it anchors trust. If all of us think that there's different versions of truth, then there's no anchor that anchors the trust in society. And by the way, trust in game theory's definition is dependencies to create mutually beneficial outcomes. In other words, if there's no truth, we cannot create a more trusting, more beneficial, mutually beneficial, and a better world. All right, so I talk about AI ML. I talk about what the problem statement is, what is misinformation, disinformation, and truth. Let's talk about how we can solve it. And then I'll try to leave the last 10 minutes for your questions. So truth is high dimensional, so we need a holistic approach to solve it. And these are the different ways combine together so that we can actually get closer to it. So the first is detection, basically using machine learning models to detect machine-generated models, generated outputs. Right. So you just use a combination of supervised learning, statistical computing, and so on to actually detect it. There's a couple examples, like for example, Detect GPT, OpenAI's AI classifiers, which by the way, like I think a year ago, it got deprecated because the accuracy is not great. In other words, you cannot consistently predict that this is actually generated by AI or not. Right? So it is a constant cat and mouse game, and as far as I know at this moment, generative AI is actually winning at this moment. This is authentication. Authentication is defined in security as the linking the digital identity to the physical self. Right? So it's one of there's multiple factors in authentication. There's inherence, who we are. There is possession, what we have. Like for example, you get the SMS one-time passcode, that's a possession factor. There's knowledge, like passwords, all things that you know. There's location, and so on, so on, so on. So inherence is exciting, biometrics like Face IDs and so on, because you can't really fake it, right? And by the way, it's very, very privacy preserving as well. I can talk about that if you're curious. But it's about proving that it's a human, not an AI. Actually, about last week, I invited the OpenAI researchers at W3C CCG to talk about personhood credentials and proof of personhood and proof of humanity. Even OpenAI recognizes that this is a huge issue. Right? And they're proposing how we can solve this problem. But fundamentally, it's about inherence and biometrics, right? And then combined with a zero knowledge sharing, zero knowledge proof, and so on, so that it's privacy preserving to prove that you are indeed human, not AI. Digital signatures, it's actually leveraging cryptography to ensure data integrity, and it's tamper-proof. Okay. And by the way, cryptography cannot be broken by AI because it's based on a completely different computer science principles. It's called computational hardness. Okay. So in other words, if you have a key, you encrypt something into a gibberish, it's practically infeasible. The technical term is called intractable. Practically infeasible to actually get that back unless you know the key. And there's multiple different applications, but in this application of cryptography, it's called digital signatures. Basically, the signer is using the private key that only the signer knows to sign something and generate a proof. Right? And proof is literally just sounds gibberish, okay? And it looks like they call it proof or signature. And then the verifier takes that signature, uses a public key to verify that it is indeed come from the signers. If you actually change anything in that document, even a character changes, that proof will invalidate. That proof will say false. So it is a technology, and by the way, if you're curious, there's multiple ways to do it. Earlier, someone was asking me about quantum computing. The historical way of doing it is using prime number factorization. But nowadays, actually, most of the cryptography is using elliptical curve base, and there's post-quantum, like lattice-based things. So these things cannot be broken by GPUs or NPUs. This is very computational intensive to do. Criteria of truth. So earlier I talked about the philosophical approach. By the way, this is not really philosophy. This is happening at Spokeo today. Okay, so imagine Spokeo is one of the biggest data aggregators. So we have 20 billion records. Actually, the technical term is claims. Claims is a set, credentials. Credentials. A credential is a set of claims made by someone about someone else. So we have about 20 billion of them, and then we try to link them into about 600 million person entities. Well, guess what? There's are multiple conflicting claims about even someone's age. Okay, so a source, technical term is called issuer. An issuer can say, "Hey, I'm 40 or 38." Maybe because their system forgot to update. I'm actually 42. But no, the source of truth, not source of truth, but the most authoritative issuer on the date field in the United States is actually DMV. Okay, it's actually driver license. It says I'm 42, right? So how do we know which claim or which credential is actually the true one? So we use different algorithms. One is authority, right? Earlier I mentioned that DMV is the authoritative source for date of birth. Date of death is actually Social Security Administration, okay? So you use authority, you use consensus, you look at you corroborate multiple issuers' data to see if there's some kind of consensus. You look at time, and so on, and so on, and so on. So this is actually not a philosophical exercise. This is actually happening in real world, in production, as we speak today. Provenance. Provenance is the 6 W's of data, the metadata. The 6 W's are who, what, when, where, how, why, and so on, so on, so on. This is actually very, very hard to do. Now imagine like, hey, why is it so hard like to know where your data comes from and so on and so on? It's actually very, very hard because in the data life cycle, when you get the data, it doesn't just spit out, okay? It goes through multiple systems, and every system will have some kind of transformation. Right? And transformation can be good ones like standardization, or it can be errors. Okay? So let me give a very classical example. So we bring in a name, for example, a name coming in. There can be different formats. It can be all caps. So our backend, our data team, will camel case it, right? Or do something about it. And then the front end will do it again, right? So what if there's conflicts? You know, different business logic and different transformations can happen in multiple different layers. So this is actually a very, very hard thing to do. And actually, we, Spokeo, are one of the few companies that I know. I think there's only actually, we're the only company that I know have full lineage and full provenance. And then, in Web3, people talk about using blockchains and distributed ledgers to actually have transparency around provenance. This is actually one of the biggest Web3 applications. But provenance is something very, very important. And it sounds easy, but it's actually very, very hard to achieve. Trust frameworks. This is very, very key. So what is a trust framework? Trust framework is a set of policies, standards, and agreements for trusting interactions within an ecosystem. You answer the questions like, hey, who to trust, and so on, so on, so on. At the end of the day, technology is just a tool to help us solve problems. Ultimately, it goes back to the humans. You can use the craziest, the lithium, post-quantum cryptography, right? It sounds very, very cool, but guess what? If your identifier is a fake one, if the authentication is not good, if there's no great identity assurance, that identifier will just be fake, will just create gibberish, right? You can have the best cryptography to secure it, to ensure data integrity, but if your origin is bad, how do you solve that? How do you know all these identifiers? Or in the decentralized Web3 world, there's a standard called decentralized identifiers. How do you know which one can be trusted? It goes back to the humans. Even large language models, by the way, if you look it up, the biggest innovation OpenAI introduced, right, in the large language model world is something called reinforcement learning with human feedback. The key word is human feedback. It's talking about leveraging human labels and human inputs and human preferences to actually train the model. Otherwise, the model will look machine, not human. So it comes back to the humans. Trust, as I mentioned in the game theory definition, is dependencies that creates mutually beneficial outcomes. At the end of the day, the players in the game theories are humans. So it has to get back to the humans. Talking about technology that's going to replace that, talking about the best thing that's going to secure this and secure that lineage and all that stuff. At the end of the day, I think this is one of the most important things to solve is trust frameworks. And lastly but not least, this is very important, is education. Because fear of unknowns rises from a lack of understanding. A lot of people fear that AI is going to take over humanity, it's going to kill us. Right? Well, is it going to replace some jobs? Most likely. Okay? But guess what? Like 100 years ago, 80% of the United States population are farmers. And now it's less than 8%. Are we dead? Do we have lack of food? Right? So things change, right? Problems change. Problem statements changes. So I think a lot of these are founded, these fears are unfounded because we don't understand it. And I think this is one of the objectives for me to give this talk is to talk about not just some hypotheticals, but really dig into how this thing works. Because once you know it, you will not be afraid about it. Once you know its pros and cons, you will realize that it's not a panacea that solves everything. I'm old enough to hear this thing that claims that it will solve all problems, starting with graph databases. Everything will be a graph, okay? Everything is linked data. The semantic web is going to replace it's going to collect human knowledge, and we're going to be able to do traversals and all that stuff. Don't get me started. Wasted $5 million of Spokeo dollars. Okay. And then in 2018, 2020s, we hear about the distributed ledgers, or so-called blockchains. That's going to save the world. That's going to, decentralize everything, right? By the way, I'm a believer in that. I'm in the Web3 community, but it's not going to save the world. Okay, it's just not, right? In a permission setting, it's just a very, very bad append-only database. Okay, so it's only a non-permission, permissionless setting. It becomes the transparency around it creates new trust. That's what it is. Okay, it's not going to create new medicines or save the world. I really believe that large language models is a revolution, probably bigger than the internet and the mobile app before it. But that said, it's not something that's going to save and solve all the problems. And that comes from a deep understanding of how it works. Then you'll realize that there are pros and cons, and there are strengths and weaknesses in everything. So, to sum up, I think truth is worth fighting. It's not just because it's an innate human nature that we want to pursue the truth. But as I mentioned earlier, truth anchors trust, and trust creates a better world. And I think to fight for that, I think truth is really under attack today, right? Because AI personalizations, and by the way, personalization engine, recommendation engines, technically speaking, is called an information filtering system. Okay, so technically, it narrows the scope. It actually lets you not see the full picture. Right? Of course, that creates a more divisive world. Right? So I think truth has been under attack because everyone sees different perspective, sees their own echo chamber, and believe only what they want to believe. And I think we need to change that. It will be under more attack in the age of generative AI because it's so easy to create misinformation and disinformation. You know, it's really hard to fight for the truth, right? But one, I think it needs a multidisciplinary approach to do that, to achieve that. And second, I think it needs persistence. It needs a belief that there are something beautiful here that's worth fighting for. Thank you.
Thank you, Harrison, for an insightful session. We'll get into Q&A, but before we open up the floor for everyone to ask questions, I want to say it's really a pleasure to have Harrison with us. If it's not for Monte, Jade, it's hard to get such one of the greatest expert in identity in AI with us today. Thank you, Harrison.
Oh, thank you. Thank you. All right, any questions? You can ask any questions. I love live audience questions, and the tougher the better. Yes, please, Gene.
I like your description of encryption and it being mathematically intractable. Here in Pasadena, especially Caltech, there's a lot of. I like your description of encryption and how it's mathematically intractable for now. But here in Pasadena, Caltech, there's a lot of research going into quantum computing. What are your thoughts on quantum computing and solving mathematically intractable problems like encryption?
Yeah, so that's a very, very good question. So first of all, quantum computing is definitely very interesting. It's not based on binary bits. It's based on what's called qubits. I do want to clarify, I'm not an expert in this field, but the underlying thing is called superposition. Okay, so it's not just ones and zeros, it's a continuous probability. So earlier I was talking to a gentleman right there. Actually, gates, CMOS gates, the currents is also continuous too. It's just that it's looks like a very steep sigmoid function. So that's why we know it's ones and zeros. But quantum qubits works completely differently. Okay, it has its pros and cons. One of the big cons today is error correction, because when you observe it, because it has many different states, and that state is has a certain probability. So when you're observing it, it disturbs the states, and then it's actually creates a lot of error. So you need a lot of qubits to do error corrections, whereas in classical computing, you don't have that. Now, there's certain things that quantum computing is very, very good. At this moment, all I know is random number generators and breaking cryptography. That's it, okay? So, so I'm not a skeptic. I love this kind of stuff. As you guys can tell, I love science and technology. But at this moment, these are the two things that it's very, very good at. And the promise of breaking cryptography, in my opinion, is overblown. Because cryptography, just like security, is a cat and mouse game, okay? So historically speaking, the cryptography leverages prime number factorization. It's something called RSA. That way, in cryptography, when you look at the different cryptography, the names are always someone's last names. Okay, so I forgot what RSA stands for. But RSA is based on prime number factorizations. Because quantum computing is so good at random number generations and things like that, you can break that very, very fast in a reasonable time. It's not intractable to break RSAs. But that said, most of the cryptography today are elliptical curve cryptography. That is hard even for quantum computing to break. And if people are afraid, you just make the key size bigger. And the key size is making that number super, super big. So even quantum computing has to take a long time. Now, what if you want to have a post-quantum cryptography with a reasonable key size, meaning that it's a small one? Then you have to you move to something called lattice-based post-quantum cryptography. But at the end of the day, it's a cat and mouse game, right? There's going to be new developments, but guess what? The new security technology will also evolve as well. Mm-hmm. Please.
quantum physics says truth is probabilistic. How does machine learning or AI deal with that?
So we need to talk about what machine learning and AI is. So today I mostly describe supervised learning, and then the large language models. I didn't get really that deep into reinforcement learning. So the difference between supervised and reinforcement learning, in my opinion, the best analogy is in statistics. So let me summarize summarize first, and I'll go into the details. So, in my opinion, today most of the machine learning models are a type of statistics. Okay. Now, if you're going to call it superhuman intelligence, that's your belief, right? I personally don't believe that. Okay. For example, we already know that the neurons, the biological neurons, their activation function is not ReLU, regulated linear unit, or sigmoid function. We already know that. Artificial neurons activation function is that, right? So there's still a lot of differences. So I don't believe that the machine learning approaches today is human-like. Okay, so let me put it out there. Now, it's mostly statistics, and in statistics, there's two types. One is what's called a frequentist approach. That's what most of us learn. The other one is called Bayesian. Okay, Bayesian is what scientists like to believe. Right? So frequentist is basically, hey, here's a distribution. Let's do observations and samples. Let's extrapolate the underlying truth. Okay. We call it predictions. I actually don't like that word. I think the better word using frequentist approach is called extrapolation, because prediction is implying that you are generating unknowns. But extrapolation, it's not unknown. It's about uncovering unknowns. And there's a difference between generating, predicting, and uncovering unknowns. And in frequentist statistics, you're uncovering it. You're uncovering and extrapolating the unknowns. Bayesian statistics leverages conditional probabilities. It's stateful. So the technical term is called Markov chain. So you chain it together, right? So you don't know the unknown. You just simulate the sequence of events from state A to B to C to D and all that stuff, and then chain it together using conditional probability. So that's reinforcement learning, actually. If you actually look it up, what is the difference between supervised and reinforcement learning? What is the difference between labels and reward functions? That's the difference, in my opinion. It's a major, major difference. So to your question about truth, does stats help uncover the truth? I think probably. Now, if truth is so multidimensional that you have to simulate it, then you can use Bayesian. But I can tell you, historically speaking, 90% of the time, frequentist statistics just wins because there's some problems with the Bayesian approach, mostly with assumption of priors. Does that answer your question? Hopefully. Please.
The question.
Yes.
You mentioned about the transformers. You mentioned about the vectors. Vector in multi dimensions, which is could be 100 billion by 100 billion. My question is, those parameters, how do you get those parameters so that my vector represents the word love? My vector represents K-I-N-G, king. How do you obtain those parameters out of those huge matrix? And do you have to go backtracking, like minimum energy loss, or do you just assign the number?
Yeah, so neural network has multiple layers. And the truth is, we still don't really know what those hidden layers, the intermediate layers are. So what it does is you have outputs, you have inputs, and use this function and multiple layers to train it. So for example, you can have, hey, these are the kings and so on, so on. Then you basically use a kind of a neural network approach to train it. You can think of neural networks as a way to automatically generate uncover nonlinear mappings between inputs and outputs. So to answer your question, do people really know what those hidden layers mean? To my knowledge, the answer is no. Like we're still, I heard some great talks in regards to how some of these, they're looking at the activated neurons in artificial neural networks, which neurons activate to when you actually see this output and so on, so on, so on. And I think my takeaway is that it actually harkens back to some of the activation regions in our brains. So actually what's exciting about the current advances in artificial intelligence is that it actually helps us to better understand how human brain works. So to answer your question in sum up, we actually, at this moment, at least I'm not aware of how these hidden layers mean, and it's still an active area of research.
Your technology, the complex 100 billion by 100 billion matrix. Are you guys trying to learn from the human brain, or you guys try to simulate the behavior of human brain? Because human brain doesn't need those feedbacks. It knows right away. You, Harrison, I forget the last name, but it's Tang, right?
Mm-hmm.
So I was able to, boom, pick up without training myself. I look at the words and say, oh, that's Harrison. Now, your AI, is it as intelligent as human brain? The mechanism, the foundation, fundamental theory behind
So-
the working of the brain.
That's a good question. So I want to first clarify when you said your AI, your models, implying that we Spokeo train the models. No, we don't train the models, okay? So actually Spokeo's main technology is distributed computing, linking entity resolutions. Actually, we're quite advanced in cryptography and security as well. Like I co-chair W3C CCG. But that said, we don't train our own models. We don't build foundational models. So I just want to clarify that, okay? But to answer your question, yes, one of the reasons why I don't think the current approach is human-like, okay? By the way, it can be better than humans. Like, for example, computers' memory is way better than humans. I already forgot a lot of things, okay? I'm getting kind of old. And computer doesn't forget, right? So, and by the way, when we talk about artificial general intelligence, right, people ask me, hey, what do you think of artificial general intelligence? If you're defining artificial general intelligence as multimodal AI, then it's already happening, right? But then if you're defining it like human-like AI, I don't think we're there yet. And one of the reasons is because, yes, you're right. Human does not have to read the entire internet to learn those things. My little boys there, right? They don't even read that many books, to be very frank. They just watch iPad all the time. But they definitely did not read all the books in human knowledge, all the internet to learn these things, right? So yes, there is definitely a difference between human and machine intelligence. But that said, I do want to point out there's pros and cons, right? There are certain things that machine does better than us, right? Such as have cross-domain knowledge. Well, guess what? It reads the entire internet. So it knows biology, it knows like stats, it knows social sciences better than any single one of us. But it does need a lot of data to train. And humans don't need that many data to train. Yeah.
Question up there.
Rivest, Shamir, and Adam.
Oh, great.
I
Wow.
go to the RSA conference pretty often, consistently. So I know this world. When you have authorities like DMV and Social Security, and you're relying on their data inputs, right? I would say like Social Security probably on an average year has like 15,000 people, excuse me, who are alive but send out death certificates. Or you have errors, human errors, and how do you perceive that when you're deciphering things? What's your thought process, or what have you done, or would like to see when you have errors, and what kind of resolutions have you done to make, to quantify what the truth, or what relationship aspects that you think, because truth can change and evolve, right? And so I'd like to know your opinions on that.
Yeah, that's a very, very good question. The answer is yes, you do need multiple criteria. On that particular example about the death information, we weigh quite a bit on the authority criteria. So in other words, if Social Security Administration actually made an error, our system will have an error as well because the authority criteria is so strong, right? So there are other criteria, which is the consensus, right? Majority and like number. You basically have to corroborate multiple sources.
Or the person, right?
Hmm?
Or the person who's alive, right?
Yes, that's correspondence. But then the person who's alive, the data subject might lie too. So even the claims from the data subject itself could be not so dependable. Like for example, earlier I was talking to CFPB, Consumer Financial Protection Bureau, and then they were thinking about making criminal records FCRA consent-based. I was like, I don't think criminals is going to let consent to police to find them. I'm not sure it makes sense. Right? So there's definitely, right? If I owe you money, I'm not going to be like, hey, call me at this number at 5 o'clock, right? Like, I'm not going to do that, right? So yes, it's definitely very context-based. It's a very, very tough problem. But to answer your question, it is you have to use multiple criteria. And then one of the biggest problems at Spokeo today, there's a couple of problems. One is the amount of labels is fewer, right? Because our problem deal with personal identifiable information, and those things have to be in a secure format, okay? I cannot actually access it, right? And then, yes, people can talk about homomorphic encryption. It sounds like if you can actually know what RSA stands for, you probably know homomorphic encryption. Yeah, so yes, you can do those kind of things, but those are really, really slow. Like I asked my co-founder to try it. He's like, this piece of, it's so slow, it's not going to scale, right? So yes, there's a lot of developments, cutting edge developments in this area. But long story short, because of all these security environment requirements, we actually don't have that many labels. Like earlier, I talked about national poll example, right? There's already errors and discrepancies when you're sampling 1,000, right, out of 300 million. What if you only have 500 samples? The less you have, the worse it gets, right? So that's the first problem. And the second problem is the criteria that we have is too much, right? So how do you actually automate it, right? Like it's impossible for even a team of 5 people or 10 people, right, to actually look through and check like 1 million records on every single build, right? It's not feasible. It's economically prohibitive. So how do you actually automate that? So those are the big challenges that we're continuing to solve. Mm-hmm.
Other questions? Go around.
And by the way, like I should have guessed RSS stands for Shamir because Shamir secret sharing. But good one. Yeah, good one. Uh-huh.
Yeah.
Please.
I'd like to ask a maybe simple, maybe complicated question.
Uh-huh.
Because Elon Musk said that AI will become self-learning. Okay, that's what scare me. And in your estimate, how soon you think AI can become self-learning? That's my first question. My second question is very simple. You suggest us to join the World Wide Web Consortium. Can you briefly introduce that to us? Thank you.
Oh, thank you. Yeah, you can join the W3C Credentials Communities Group. It's actually free and open to public. And then I post up the agenda. Some of them are quite technical, like we talk about like BBS, zero knowledge proof, those kind of things. You probably don't want to join those kind of things. But yeah, sometimes it's a little bit less technical, like the OpenAI credentials, personhood credentials talk. Actually, 3 weeks later, I got the creator of TLS, Transport Layer Security, which is what secures your browser protocols, Christopher Allen, to talk about edge identifiers. So that one I would recommend. So you can just go search on Google and then join, okay? And then, or you can just ask me, right? Harrison@spokeo.com, Tang Talks, because I talk a lot, so that's my handle. But but that's on the W3C side of things. You can actually look at the agenda. We invite different speakers every week. What's your first question? Sorry. Elon Musk. That's right. You know, this is I didn't hear that talk, so I don't know what he's referring to. But that said, I think most likely he's talking about agency. So what agency is agent is defined as something that acts on your behalf. And right now, the hottest area of research in language models and AI is this idea of automatic agents, okay? That can actually help you automate a lot of things. So for example, we have an agent that automates the pipelines, right? Through multiple inferencing. So inference in large language model context is post-training. So once you train the model, it calculates, it runs the model to generate the output. That's called inferencing. So through scaling the inferencing, the latest OpenAI Strawberry 01 model is about scaling inferencing. So you just like scale the outputs, they chain multiple prompts and results together to actually kind of like, analogy I would use is that, for example, my son is doing math, right? Like 5 plus 3 equal 8. They use related facts. The related facts are a minus 3 equal 5. Now, if you calculate a minus 3 equal 4, then you know something's wrong. So you're using different perspectives, right? Different inferencing to get closer to the truth, right? To look for consistency in those perspectives. So I think that's what he's talking about. Another one interesting thing about AI agents is simulation. So earlier I was at Stanford listening to my dorm mate's talk. He's now a Stanford professor, talking about how AI agents can help simulate, run simulations. And the output of simulation is the same as the human ones, right? So I think that's what Elon Musk is talking about. Will it replace humans? I fundamentally think that the way our human brain works and the artificial neural network today works is, at least today, is fundamentally different. So I don't think it's superhuman. It probably can do certain things better than us. Like for example, when it runs inferencing, it runs a lot faster, right? Like I don't think we can run 1,000 inferencing in like 5 seconds. I cannot do that. Maybe you can, but right? So certain things I think they can do better, but that said, is it really human-like? I don't know, right?
Okay.
Maybe one last question, right?
One last
One last question.
question.
Yeah, please.
Thank you, Harrison.
Yeah.
I'm wondering if there's potentially a correlation between truth, like a physical correlation between truth and energy, that the amount of computation required to get an accurate perspective consumes X amount of calories or X amount of units of energy.
That's a very deep one. I haven't thought about that question, but So Jim will answer that in his talk. But yeah, I think that's a very interesting perspective. This is why these kind of conference is good, right? It's a two-way conversation. So, but yeah, great one, Robbie. All right, cool, thanks.
All right, thank you, Harrison, for your talk and a live Q&A session. So